Good morning, everyone. Today we will start with the Chapter 12, Part 1, Grouping of Lamps and Cells. In the previous lesson, we learned how to measure current and voltage. In Chapter 12, we will discuss how to group lamps and dry cells in a circuit. At the end of this lesson, you will be able to differentiate between parallel and series grouping, indicate how dry cells can be grouped in series, identify when dry cells are grouped in opposition, and finally calculate the voltage across a group of dry cells. To study the grouping of lamps, we will construct several circuits using a dry cell, two lamps, and of course some wires. Let's start with the first case. First, we will get a dry cell and use a wire to connect the dry cell to the lamp. Now we will connect the second lamp. In this case, we will place the second lamp beside the first one. Then we will close the circuit using wires. So in this case, the lamps are grouped in series, where they are connected beside each other. And as you can observe in the figure, the current travels in one path only. So what will happen if we remove one of these lamps? Observe the figure carefully. In series connection, if we remove one of the lamps, the other lamp will not light because the electric current travels in one path only. Let's start with the second case. We will also use a battery, two lamps and wires. First, we will get the dry cell and use a wire to connect it to the first lamp. However, this time we will not place the second lamp beside the first one. We will place it below the first lamp. So now the two lamps are parallel to each other. Then we will close the circuit using wires. This is the case of parallel connection, where the two lamps are not connected next to each other. If you notice the figure well, the current divides and travels in two separate paths. In parallel connection, if we remove one lamp, the other remains lit, since the current travels in different paths across each lamp. So lamps can be grouped in two different ways: series connection, where they are connected next to each other, and parallel connection, where they are parallel to each other. In application 1, observe the circuits well and state whether the lamps are grouped in series or parallel. Then construct an electric diagram of each. Revise Chapter 10 to remember the symbols of a dry cell and a lamp. Don't forget to pause the video, then check your answers. So in Circuit 1, the lamps are connected in parallel, while in Circuit 2, they are in series because they are next to each other. We already know from previous chapters that a dry cell has two poles, a negative pole and a positive pole. Notice the following diagram. The positive pole of the first dry cell is connected to the negative pole of the second dry cell. Then we say they are connected in series. This is how you connect the dry cells in a flashlight. In this case, the voltage is added up. So the total voltage of these two dry cells is equal to 3 plus 3 equal to 6 volt. As you can observe in this second figure, the positive pole of the first dry cell is connected to the positive pole of the second dry cell. Then the dry cells are connected in opposition. In this case, we subtract the voltage of this grouping. So the total voltage is equal to 3 minus 1.5 equal to 1.5 volt. In application 2, you are asked to state whether the dry cells are connected in series or opposition. Then you have to calculate the voltage across each grouping. In the first case, they are grouped in series, then we add the voltage, while in the second case, they are grouped in opposition and we subtract the voltage. Remember that we can use more than two dry cells in each circuit. Please study the notes well and solve the application, then open your books to page 103 and solve numbers 7, 9, and 10. Stay safe, everyone.